Well, hello again. So, well, as I was saying, as a Python developer, sometimes we tend to use a lot of lists and dicts, and the reason is very simple. They are like, the API is very, I would say friendly. They are very quick. They can allow us to do many things in a very intuitive way, and they even have a very computational properties. I mean, behind the dict there's a hash table, which accessing by key, it's big O1, so it's constant time, and it's good for, for developing and for fast prototyping. And that's, and also mainly if you are in a backend, you probably are exposing an API. That API, it's very common to be like in a JSON format in the response of the body, and the dict is like, fits like very well for that, and it's like, it's a very pro use case for us. And also, as Python backend developers, we sometimes tend to forget. Some developers owned by the scientific community, they are using a lot Python, and they have some great libraries that might help us in a lot of times when processing big data structures that we also have to do when we have big queries in our server. So we're here in Barcelona. We are all developing the hotels product of Skyscanner, and well, it's just a minor introduction. What I'm going to talk about later on is about hotels. For each hotel, we keep a relation of partners with prices. We also have filters for this query, and we also have a sorting relevance option for the query. Okay, so just to present the hotels, when I'm talking about partners, hotels, filters, and sorting, it's just, this is the website, so we as an API will have to be dealing with this. Okay. And our use case, our product right now requests up to 2,000 hotels for each query. You can, there are some cities that has more than 2,000 queries. Not many. It says only Barcelona, Paris, Beijing, London. For the rest of them, we query for all the hotels in that city. And well, we also can query for you. A user can query for all prices in Spain. I don't know what aiming to, but they can query about that. But we only will be retrieving prices for most 2,000 hotels. For each hotel, we request prices for all the partners that we have. For some, let's say that for many hotels, it can be like more than 10 partners per hotel. Okay, and also we need to go to data stores and get all the content for that hotels, the images, the descriptions, and all these things. And also we need to store some tips for sorting. The sorting thing is a very important factor in our product, because only 5% of the users go to the next page when in the site. Okay. And yes, when you're talking about for a hotel, we store prices for each hotel, then we content orator for that hotel, and some things for sorting. Yeah. So basic thing is we end up using a huge dictionary for storing everything. Here, don't worry about anything. This is a real dictionary from a query. The most important thing, maybe, this is the dictionary, initial tick prices. Inside, we are storing by the hotel ID each hotel. Inside each hotel, so I can only be showing here one hotel. There's the OBJ thing, that it's self-explanatory as the information data package, which means that all the content, description, all the coordinates for that hotel, or where it's located in terms of which district in Barcelona, for example, all the, let's say, all the static information for that hotel. Then there's one thing here that it's another dictionary, which is a price info. We keep recording all the prices for that given hotel. Here at the bottom there are the, let's say, the sorting keys, tips for the hotel. That we use that number to sort. The biggest, the higher this number is, it's at the top of the list, and so it's an important key. And finally, there's this values thing that I have to take myself a picture of. expanding it, and it keeps all the prices that we have requested for each partner. Okay, and that's done for 2,000 hotels. And one thing I wanted to stress is just because it's very complicated to understand here doesn't mean that it has to be that complicated. If it has been thought at the beginning with a more, you know, structural thing or a better design. Okay. Yes, one other thing that sometimes to the backend developers happens to us is like we start with a dict, it only has 5 attributes, it ends up something like what I have shown now to you, and sometimes you reach the point that you say, okay, now I have to do it again, and things get complicated. Good things of this data structure that, well, so given hash tree properties of the dictionary, random access to any hotel is big-O1, as we have said. Sorting of the hotels, because it's so difficult, we rely on a data store to give us the sorting of the relevance factor. So we just get the list of IDs sorted, and then we have to iterate, well, go for each ID and going for, let's say, create a new list and taking the hotel in the position order. Okay, so it's ON, which is quite good. And well, yes, of course, you've got the dictionary, and all the content for that hotel is very close to the place that you want to use for that hotel. Okay. The bad. We like sometimes users, and as a product, we are very interested in filters for dynamic properties. Dynamic properties means that they come with a price. So the parent says, okay, this price has breakfast included. This price has cancellation, free cancellation. So we need to iterate all over the prices of all over the partners of all over the hotels in order to get a new, like, let's say, work area or dictionary, of course, with new prices, just taking out the ones that we are interested on. Sorting for prices, I also put it in the back because yes, it's ON in the way that we do that, but the thing is that data structure is so difficult and so complicated that iterating all over the structure is very expensive. Meaning that it's just because you are doing a lot of memory transferring. So it's just a big object goes to memory, and you have to, well, check the thing, compare it with other ones. So I mean, in the end, is performance-wise is not really the best way. And the way that we've got this structure, it makes us very difficult to share. That's a very internal thing of the design. But if you ask for prices for the hotels in Raval, we cannot share right now if there is a previous query that has already asked for prices in Barcelona, which some of them are in the Raval, as you expected. Okay, but well, I mean, this is because the structure and the AGI. Well, that structure that I have shown to you, it really is devastating in terms of memory. Only with 2,000 hotels, and we can only, right now, more or less, allow us to store 100 pieces of that into 52 gigabytes of memory, and then the memory just disappears from your, and you don't get to know where it has gone. Okay. And as I'm going to show you right now in a little bit of time, we are performing a lot of loops. As I've said, it's a very poor in the performance, but what's one the idea? Behind our server is a twisted framework. Twisted, for who, if anyone doesn't know, it was a very, well, I'd say it was a very popular in Python 2. It's very popular in Python 2 for a server. Python 3 now is with Async.io, everybody's going to that, but nobody has Python 3. You arrive to some place and everything is there. So, well, important thing of the twisted framework, it's only one thread. It means to be like that. Everybody tells you, like, don't block this, don't use an IO blocking call here. But seems like nobody, it's not like that heavy stress that sometimes when you're blocking your servers with the CPU usage, with the JSON logs and with the loops and with iterations, and really there you can have some problems there. And well, time to rethink it. So it was, I mean, these are like fresh ideas I got in the aeroport in Bilbao. So it's like, what if instead of this document-based storage in memory with the dicts and the list and all these things, just working with an in-memory table storage that would at least allow well, reducing the amount of redundancy, just because you wouldn't be copying all the attributes names, and you also may expect that with a data structure that has less footprint, it would probably be faster when you are comparing it, when you are working with it. And then I discovered Pandas, which is a library that's awesome for data processing and scientific things, but it could be very useful for us also. So what's Pandas? Pandas is, in their own words, it's a tabular. At its main core, it's a tabular structure, the data frame, and it really has an awesome interface for querying and filtering and even sorting. Really, so it was very good to. It was very easy to test and to make a proof of concept. So it really means that the library is very, and well, the performance is also awesome. And now it's a proof of concept. So what we did in the first thing, we just hack a little with the server. Well, I just do with a branch, and we bulk all the prices for a given query, for a big query. That thing, I think this one is for Paris. So a lot of hotels are involved here, like 4,000 prices more or less in average, and just use Pandas. We bulk everything into a CSV file, and we load it. I mean, and here we have like the output of the structure. This is like the notebook that I was just previously presented, but only the print screen, just to make everything self-contained. Okay. Here you can see like, well, it's probably more or less like the same that before, but just more like nicer, more tedious. It feels like it's easy to work with this, okay? And let's do a quick comparison. Sorting. I'm gonna talk only on 3 main points: sorting, filtering, and grouping by. Yeah. What's this? So I cannot dare to show my code, not because of private concerns and all these things, just because it's really impossible to read. I mean, but our code has, our server has some kind of profiling tool that allows us for each query to know where does the time go. Okay, so each time a request arrives, we can just check how does it go, and this is like well, the front end. So all the clients do some polling to us. That's when you see all that the prices are refreshing. It's because there is a polling behind. It's more or less the average is 4 or 5 requests per query, let's say. So here I'm checking just one in the middle, not the most important one, not the one that takes more time, just one in the middle. When you are supposed to have everything cached in memory, more like it should be like more easy to access, so less time to acquire. And well, more or less what I can see here, I can tell you is that this is like getting all this first dictionary that I have shown you at the beginning, sorting the prices, taking only the ones, the most important ones, copying them into another data structure, because you don't want, if somebody changes if you change the sort order for a given request, if another user is using the same work area, because we try to reuse the work areas, I mean a query, for work area, you need to like detach how you process the sorting of this specific request from the ones that it's for the other users. Okay. Once you have everything copied, everything sorted, you do a little bit of, well, prepare another JSON object that will be the one for the response, and finally you serve it. We spend here this 180 18 milliseconds. Okay. Just to be clear about the magnitude of this tragedy is that a thread is a thread, and in Twisted Server you only have one thread. At least you should only be using one thread. So, with this amount of time doing this task, you can only, and 1 second is 1 second, so you can only get 9 requests here. It's like this piece of code is taking like a very big portion of the request that should be much more taken. Okay. And what if we do with pandas? So here, just I'm timing this. I'm using the tabular structure. I'm sorting by just the dynamic sorting in the first place, the price in the second, doing some ascending, blah blah blah. Finally, it's 2.18 milliseconds, and it's a piece of code that I can show you because it's very nice and clean. So that's very interesting. Filtering. So I told you about the cancellation policy, that it was a dynamic thing. Some prices has cancellation policy and some other no. Again, I really, it's a shame that I cannot use our code because it's really crap. So, but I can show you at least the profiling of that operation. It took 25 milliseconds to do all the mangling of going to all the prices of all the hotels of all the, well, at least only the ones that were selected, so it's only a few that, 25 milliseconds. And the same again with Panda, we just, after you loaded the work area, and you say, hey, so just give me all the ones that have cancellation code equals to 1, which is our internal code for code, so it's not even a millisecond. One even more thing, we do not dare to, when in our current base code, when we are saying cancellation, free cancellation into the filtering, we are only taking into account the cheapest price for each hotel, because performance-wise, we cannot allow to go for each partner price. Inside the partner, they give several prices. Some are more cheaper than the others just because they include these things. So we are not really now being able to do this because it would be like no way. And with this, because I have loaded into the Panda all the prices and all the room offers for all the hotels from all the partners, it's just so easy. First doing this filtering and then speak about it later. And the group by, where do we use the group by? So here we just do analyzing all the prices and do accounting and grouping by the prices. Okay, this is 10 nights, so this is why the prices are so expensive. Okay. Again, so I have not put, I think, our price. So, and this, how would we do this with Panda? So, it's already included. It's just using, if you take into account, well, if you start looking deep into the API, there's this function called cut, and then you count all the values, and finally you get a result. Again, it's under the millisecond. It's awesome. So, conclusions. When using the, for us, it's using the structure behind the scenes. It really matches most of our use cases and really eases a lot the processing of the request. Okay. Our base code iterates several times for solving all the use cases. With Panda it will be more or less like the same, but because queries have to be solved, whatever you do, even it's tabular structure. But at least just because the row of a table is much less info, you are expecting that the CPU it will be maximizing the cache and all the structures there. Okay. And also we expect to use much lower memory usage when using this structure. That's it. So, any questions?
Okay, 2 questions. The big one, why are you doing this in memory in real time instead of using a database? And the second one, why doing it in real time when you could have this pre-calculated and stored in Redis, maybe, I don't know.
So, it's real time because it was the first design as we were told, it was supposed to not. I mean, it has to be very quick answering the user. So it was like not good. In the beginning, it was not a very good approach to use another data structure. Okay. And the second one about the Redis thing, I have to confess that I think we need to have a distributed system to use this, because well, if we want to scale the Panda thing, at least as far as I know, I am showing you like a library that you will put inside the process, so that doesn't scale. And we are considering now plenty of choices. We are, and one of them is Redis, in order to distribute the thing and to store the thing there. But well, Redis, as far as I know, it's key value storage.
No, it's many things.
It's many things.
You have key value, but you have more things. You have lists. You have sorted. You have a lot of data structures.
Actually, you could consider something like Elasticsearch, which is quite useful for that kind of use cases. Also, unless you need real to have the prices are changing very often. Unless that, then you can have a lazy load that it's indexed in many places when they come.
Prices have to be right now for your government cached for 15 minutes. No more than that.
It's okay because how many prices can you have per partner?
Prices per partner?
Tens?
Not that many. Per hotel, you mean?
So yeah, per partner and hotel. Yeah.
It's 2 or 3.
2 or 3.
No, not many offers.
So it's 40,000 prices to update every 15 minutes. Elasticsearch could manage this. Well, I mean, if the Pandas is going well for you, it's much better to use.
No. I mean, it's almost discarded in the sense that it's not. It doesn't scale for us. I mean, we cannot. I mean, because right now, one thing I have not told you is that we are using a stickiness thing in order that because all this data structure is stored in one CPU, all the requests from a client has to go to that same CPU, and we want to avoid that. Okay, to the process. So
I don't know about Redis when working in distributed mode, but Elasticsearch is quite good at that.
Yeah. Or MongoDB, you could do the sort directly on the database without needing to do anything. I have one question, if you allow me. The thing is, for what I've seen, maybe I misunderstood, but you took a subset of the data you had in the huge data structure you had in Python, and you loaded that into Pandas. And then you did all the sorting in Pandas, right? Mm-hmm. Why don't you just do the queries in the subset instead of doing it in the huge mass of complicated objects? So if you have a small array, like the one you're loading into Pandas, instead of just iterating through the whole dictionary.
You mean split the whole data structure?
Yeah, just have like a view of the total structure, and then you just make the searches and everything in the view, and then you get the total ID, and with that you can go to the initial object and just get the information you need. So the searching, the sorting and everything you do in a subset that is fast, and you can basically use NumPy or Pandas or whatever to handle the data. Then you go back to the main database to get the rest of the information you need, and you get the best of both worlds.
Yeah, I mean, we will have to. I mean, that's a very good point. We will have to keep using the big data structure, because for the content of the hotels, for example, I'm trying. I mean, the first idea, if we would using Panda, would be like, I guess it's the way you go. I mean, it's like using like the data, all the descriptions, all the images into a data structure that's suited for that. That is like a big dictionary, and then doing all the processing into a much faster, into a more suitable. Like would be the Panda, like split all of the two worlds. That's a key point into this. I mean, we arrive, we see that, and we are trying to think about how to improve that.
How difficult would it be for you to use different servers which is different from Twisted, something which is not just single thread and give you more time in that area. I mean, I know this is not like the solution to your problem, but how difficult would it be for your company to move from Twisted to another thing, which is not single thread?
Which is the other thing? I mean, just this.
Another server, I think, another web server.
Well, I mean, obviously, we are thinking about building like the core of everything. So, but we are really also thinking keep using asynchronous technology because it's really good from performance-wise, especially because we are, like, as you can imagine, we are doing a lot of I/O thing, a layout request into our own data storage, just to get all the content for that hotel, and for every partner is a request, an external request, okay? And I don't really, well, my idea, I mean, of course I can be wrong, but a multi-threaded server here, maybe with the I/O thing, will fail a little bit. That's just my.
Did you guys try something besides Panda? Because like it says, Elasticsearch has like a really good cluster solution. You just put 2 servers with Elasticsearch, and they manage they create as a cluster for, and it's really fast indexing. We use it once in our company, and it was.
So we are using currently Elasticsearch for the login mechanism, but I have never thought that it would be a solution for this. So just for this, the presentation is very awesome for me. You just mentioned before Mongo. We have for analyzed Mongo as well. We have not already reached the moment that we compare everything and say, okay, we are going for this solution. So it's in the table, Mongo release as well. Elasticsearch was not on the table, so now it probably will be. And we will also think about Postgres because, well, I mean, I think it's a very good in technology also, especially because of all the sorting, grouping, and all the querying thing. So it could be useful, but it's true that it doesn't scale as much as you wanted. It's a little bit difficult with this the sharding things that it has. It's not really integrated into the core of the system, but it's also on the table. Okay. So. Sí, vale, bueno, ahora tenim pizzas y cervezas.
In English, please. Just a minute. Those nice guys at Skyscanner, they are providing us with pizza and beer. I think you understood.
We can go to the kitchen.
Thank them.